Good morning. This is Engage New York 6th grade, Module 3, Lesson 16, about symmetry on a coordinate plane. On the board, I have two vocabulary words that you should be familiar with. Symmetry and reflection are both geometry words. Symmetry, or a line of symmetry, is when a shape or a point has two or more identical parts. And today we're going to be talking about mirrored parts. So if a shape has a line of symmetry, for instance, a rectangle, this rectangle can be cut into these two parts, and if we folded them on that line of symmetry, they would match up exactly. Now, this is not the only line of symmetry for the rectangle. We could also make a vertical line of symmetry, and if they folded together there, it would also line up exactly. These would be two identical parts. Now, if I were to take this rectangle and make a line diagonal, when I folded on that line, they would not match up. This point would be up here, and this point would be down there. It wouldn't match up exactly. So this diagonal line is not a line of symmetry. It doesn't make two identical parts that mirror each other. So symmetry is a word that you will need to know today. Starting with the opening exercises, give an example of two opposite numbers and where they lie on a number line. So you can choose any number and its opposite. I'm going to choose the number 7. So here's the number 7. That's where it would go on the number line in reference to 0. And then so this one be its opposite at -7. So if I were going to describe where the numbers lie on the number line. So 7 is 7 units to the right of 0. That's how I would describe its location. And -7 is 7 units to the left of 0. How are they similar? What do they have in common? Well, they are both 7 units from 0. So they have the same absolute value. They have the same absolute value. How are they different? One is to the right of 0, and the other is to the left of 0. One is positive, one is negative. These are some things that they have in common. Now, when talking about symmetry, where could I fold the number line so that 7 and -7 would match up exactly? So thinking back to our rectangle, if I folded the rectangle here, both sides would match up exactly. So where could I fold the number line that the numbers would match up? We can see that their absolute value is 7. 7 units from 0, 7 units from 0. So if I folded the number line here, they should be able to match up. So their line of symmetry would be at 0 on the number line. Okay, moving down to example number 1. Locate and label the points on the coordinate plane to the right. For each given pair of points, record your observations and conjectures in the appropriate cell, paying close attention to the absolute value of the coordinates and where they lie in reference to the axis. So let's move over to our coordinate plane. Our first point is 3, 4. So my coordinate plane for this task will have a scale of 1. So 3, 4, 3 units to the right on the x-axis and 4 units up on the y-axis. This is 3, 4. Okay. The other point they've given is -3, 4. So 1, 2, negative 3, and the positive 4 would be here. Okay, so when I'm looking at the coordinates, I notice what? Similarities in the coordinates. Well, their y-coordinate is 4 for both numbers. So that's something that they have in common. And what is different about their coordinates? Well, I can see that their x-coordinates, not only are they not the same, but they are opposites. Now this chart is continued to the next page. Similarities in location. Okay, so we notice that so these are similarities in location. They're both above the x-axis. In fact, they're both 4 units above. They're 4 units above the x-axis. And they're both 3 units from the y-axis. Okay, differences in location. Well, they're in different quadrants. And they're on different sides of the y-axis. Relationship between coordinates and location on the plane. It's said to pay special attention to where they lie in reference to each axis, which we've talked about. The axis is here. Now, if I were going to fold the coordinate plane in a way so that these 2 points would match up, so if I were going to find the line of symmetry, where could I fold the coordinate plane so that they would match up? So what would the line of symmetry be? Well, if I folded it at the x-axis, so if I folded it here and went down, they would not match up. But on the y-axis, if I folded that together, this is 3 units away, this is 3 units away, so that would match up. So their line of symmetry is the y-axis. Okay, let's look at the next set of points that they've given us. So 3, 4 is going to stay the same. And then 3, 1, 2, 3, negative 4, 1, 2, 3, 4. So this point is 3, negative 4. Okay. Now let's see what these, looking at the coordinates, what is the same. Okay, so here, their x-coordinates are the same. So same coordinates. The x-coordinate is 3. What's different about the coordinates? Okay, so now our y-coordinates, not only are they not the same, but they are opposites. Okay, now let's look at their location. What's same about their location? Okay, so they are both to the right of the y-axis. And they're both 3 units from the right y-axis. Okay, let's see what is different about their location, difference in location. Okay, they're in different quadrants. They're on opposite sides of the y-axis. I'm sorry, the x-axis. They're on different sides of the x-axis. Now, if I were to find the line of symmetry for these 2 points, how could I fold the coordinate plane so that the points would match up? So the last time, we could fold the y-axis and the points would match up. Let's try that now. So here's our y-axis. If I folded it there, this would be over here and over there, so they would not match up. But if I folded it on the x-axis, it's 1, 2, 3, 4 units, 1, 2, 3, 4 units. So if I folded it on the y-axis, or the x-axis, the points would match up. So the line of symmetry is the x-axis. Okay. Now, looking at the third and final set of points they've given us, keeping 3, 4 as our initial point, and then now negative 3, 1, 2, 3, negative 4. Okay, now we're going to see what do these coordinates have in common. Okay, are their x-coordinates the same? They are not. Are the y-coordinates the same? They are not. So these coordinates don't have anything in common. So same for the coordinates? Nothing. What about difference for the coordinates? Well, our x-coordinates, they are not the same. They are opposites. Then our y-coordinates are opposite also. So the x-coordinate and the y-coordinates are opposites. Okay, let's look about their location. What is similar about their location? Well, they're on different sides of the y-axis, different sides of the x-axis. They are both 4 units from the x-axis and 3 units from the y-axis. So let's put that. There are 3 units from y-axis. There are 4 units from the x-axis. Okay, what about differences in their location? They are in different quadrants. They are on different sides of the x and y. I'm recording. Okay. Could we make a line of symmetry for these points? So somewhere that we could fold the coordinate plane so that the points would match up. If we folded it on the y-axis, this point would go here and that there, so it wouldn't match. If we folded it across on the x-axis, that would match there and there. That wouldn't work. So in looking for a line of symmetry, if we folded it diagonally across the origin, those points would line up. So diagonal across the origin. All right. Let's move down to the next exercise. We have filled out chart, and hopefully you were able to notice how they changed. So here, their y-coordinates were the same, and then the x-coordinates were the same. The x-coordinates were opposites, but then the y-coordinates were opposites. And how these kind of mirror each other. This line of symmetry was the y-axis.